Kipsters will be able to solve double discount problems. So today we're going to be looking at situations where perhaps there are multiple discounts. A lot of times you can come in, the store says, hey, this is blank % off, and you've got an extra coupon that says, hey, you can take an extra 10% off. So we're going to run into some problems like that today. The first example that we're going to see here is Mr. Boots' plane ticket goes on sale for 20% off the original price of $600. Because he's a Sky Miles Platinum member, he gets an additional 10% off. What is the final price of the ticket? So what we're going to do today is we're going to prove, or not prove, or disprove, that there are two different methods we could think about solving this particular problem, and we're going to prove or disprove that those methods give the same answer. So the first method says that we add the two discounts together and just solve this as if it was one problem. So if we were to do that, we would take our 10% and our 20%. That would tell me that we believed our discount rate to be 30%. Our original amount is $600. And that would tell us that our discount is 600 times 0.3. Doing my quick benchmarks over here, 10% would be 600 decimal 1 times 60, and 600 divided by 2 would be 300. So this better come out to be between 600 and, or 60 and 300. Multiply 18 decimal 1 time, and I get $180 is the discount. And to get my final amount, since this is a discount, do I want to add or subtract? Subtract, all right. 600 minus 180 is going to give me 420. All right. So our first answer says if we do it by method 1, it says final price is $420. All right, let's try method 2. Method 2 says that we apply one discount, and then we have to use the answer to apply the second discount. Let's see what that looks like. The original amount is $600. The first discount rate was 20%. So we get our benchmarks 10% and 50% is going to be same thing. 10% would be 60 and 50% would be 300. 600 times 0.2, 0.0021 decimal 1 time, $120. Since this is a discount, I'm going to subtract 600 minus 120. It's going to give me 480. Now, in addition to this discount of 20%, I also have a discount of 10%. So I'm going to take that 10% off of this 480. So basically, I'm going to take this, and I'm going to swing it all the way over here to my next original amount. Because 480 would be the original amount if I didn't have that extra 10% off. And I'm going to take 10% off, so 10% of 480, that's actually one of our benchmarks, so that one's going to be really easy. I just have to move the decimal over 1 time, so my additional discount is $48. So I had 480 and I'm subtracting an additional $48. and I get 432. So this one tells me the final price is $432. Kip yes or kip no? Do both methods give the same answer? Kip yes or kip no? Do both methods give the same answer? I'm looking for 100% understanding and participation here. Okay, no, both of these answers or methods don't give the same answer. So, kip yes or kip no? Are both answers correct? One of them is correct. Excellent. Now, which one do you think is correct? Please show me with your fingers. Do you believe method 1 is correct, or do you believe method 2 is correct? It's okay, I haven't told you. So it seems like most of you seem to have an understanding that life sucks, and the most difficult method is usually the correct one. And some of you are wishful thinkers and believe that I would love for method 1 to be correct because that would make my life so much easier. Unfortunately, if we look at how the real world works, there's a couple things that we can think about it. And we can look at it and we say, well, if I was a business and a customer walked in with a 20% coupon and a 10% coupon, which would I rather calculate? If I was a business. Method 2, because if I'm a business, I still charge more. Another way we can think about this is if a customer came in with a 50% coupon and another coupon that was an additional 50% off, and we added those together and did method 1, they'd have 100% off, and I would just be giving them the item. So, unfortunately, in the real world, the way that double discounts are calculated is through method 2. In order to calculate double discounts, you must apply one discount and then apply the other discount. Okay? So, we're going to look at a couple more examples here.
Oh, it has it right there.
A t-shirt goes on sale for 50% off its retail price of $32. Then the t-shirt goes on additional clearance for an additional 60% off the sales, or 65% off the sales price. What is the final price of the shirt? So this particular type of problem, when we see that there are two discounts being taken, this is a double discount. And over here it says the final sales price is blank dollars. So that tells me if I'm looking for the final sales price, I'm going to be looking for this second final amount after I've applied both discounts. So I'm going to start with discount number 1. I have an original amount of $32. I have 50% off. This is really nice because we don't actually need to do the multiplication here. This is one of our benchmarks. If it's 50% off, that means it's half. So 32 times 0.5 we know is going to be 16. Which tells us that after the first discount, 32 minus 16, it would be $16. However, thanks to it hitting the additional clearance rack, we've got that $16, and we're going to be able to take an extra 65% off. So for this one, we need to go ahead and do our benchmarks. I'm just going to do it over here just so I don't get lost. 50% and 10%. For my second discount, 10% of 16 would be $1.60. And 50% would be 8. Now that I'm looking at this, I'm wondering, Mr. Boots, that was kind of silly. 65% isn't between 10% and 50%. So I should probably do my 100%. Which would be 16. So our second discount should be between $8 and $16. So 16, our original amount, times our 0.65. Looks like an additional $10.40. So I take my $16 that it was before I took this additional discount. Oops, that's not $16. $16. And this additional discount of $10.40. I subtract. And I'm going to get $5.60. So the final price after the 2 discounts is $5.60. Joshua.
I don't really get it because if the other sale price off is 65, why would you minus them after you multiply? Wouldn't you minus off the 32?
So this is basically a brand new problem once we get to here. We've already reduced the price 50% off.
Oh, so that's canceled out.
Yeah, so it's kind of like this is not important anymore because we had the $16 and it was like, oh, this shirt costs $16. But guess what? You get 65% off.
32 is better.
Yeah. All right. Second one. Frito-Lay makes a bag of hot chips for 25 cents. Before they sell the bag to the convenience store, they mark up the price 80%. Before the convenience store sells the bag of hot chips to you, they mark up the price an additional 120%. How much does the bag of hot chips cost you? So this particular problem has 2 percentage rates, but it is not a discount, it is a markup. This is a double markup. All right, so the original price of the bag was that it was created for 0.25, 25 cents. And after that, the price was marked up 80%. So in order to find out how much that first markup is, we're going to have to multiply there. I'm going to go ahead and do my benchmarks. 80%, that's going to be between 50% and 100%. 50% would be half of 25 cents would be like 12.5 cents, 0.125. And 100% would be 0.25. 2 times. So I have 0.25 times 0.8. 0, carry the 4. And 8 times 2 is 16, plus 4 would be 20. And I'm looking at this, I've got 1, 2, 3 decimals, so 1, 2, 3 decimals. Tells me the additional markup is 20 cents. So they made it for a quarter, and they sold it to the convenience store for 0.25 plus 0.20. They sold it to the convenience store for 45 cents. The convenience store says, okay, I got this for 45 cents. I'm going to mark it up an additional 120%. Yikes. So we need to multiply 0.45 times 1.2 for my 120%. So in this case, for the second one, we only need a single benchmark here. We know that it should be, the markup should be greater than 100%, which would be 45 cents. So 0.45 times our percent, 2 times is 1.2. 1.2 0 carry the 1, write it, is 9. 0, 1 times 5 is 4. Running out of space here. 0, 4, 1, 5. And I've got 1, 2, 3 decimals, so it's an additional 54 cents. And I'm adding 54 cents to which amount? Yeah, the 45 cents. So one thing that for some of you it might help is after you've finished this first set, put a line through it, reminding you, hey, it's a new problem now. So we have the 45 cents plus the 54 cents. And the convenience store sells you the bag of hot chips for 99 cents. So how much does the bag of chips cost you? The bag of chips costs
$1. No, ask. Don't have to. They should do. Try to do it. Ask. Okay.
I can tell that this particular problem has incited a lot of
Look what I did.
personal experience. However, we need to keep ourselves on track. I need a key point or two for today's lesson. Marquita. Mm-hmm.
Make sure that when you're doing it, make sure, okay, you see how it's two different kinds of methods?
Yep.
When you're doing one of them, like, pay attention to your first one, so you know which one's
Okay. So the first, I actually hear her kind of giving me 2 points. The first one, she says, when doing double discount, double markup problems, she says you have to use method 2. And I'm going to put a star next to this so I can remind myself when I come down here and so, okay, when I read that, I also need to read what method 2 is. Method 2, apply one discount, then use the answer to apply the second discount, or markup as the case may be. The second key point is she says, to mark through used information to keep track of benchmarks OAs, etc. Well said, Marquita. Those are 2 excellent key points, and I think all that we really need for our lesson today. I'm going to ask you to move on to your together time.